What if the first journey to a parallel universe has already taken place and we just haven't realized it yet? The idea of parallel universes has long fascinated scientists, philosophers, and dreamers alike, opening doors to endless possibilities and questions about the nature of reality. Theories about parallel universes range from the mind-bending concepts of quantum mechanics to the colossal collisions of multidimensional membranes. Today, we're diving into 30 of the most fascinating theories about the universe's first parallel universe travel. From the secrets hidden in black holes to the mysteries of dark matter, each theory offers a unique glimpse into what might lie beyond our own reality. Whether it's the idea of infinite bubble universes or the possibility of crossing through wormholes, the journey we're about to embark on is as thrilling as it is mysterious. So get ready to explore the unknown, challenge your understanding of existence, and uncover the tantalizing possibilities that might just redefine everything we thought we knew about the universe. Stay with us because by the end of this video, you'll have a whole new perspective on the cosmos and the extraordinary idea that we might not be alone, not just in space but in reality itself. Now let's dive into the first theory, the quantum tunneling hypothesis. At the quantum level, particles behave in ways that defy our everyday intuition. One of the most fascinating phenomena is quantum tunneling, where particles seemingly pass through barriers that, according to classical physics, should be impossible to cross. This happens because at the quantum scale, particles exist as probabilities rather than definite positions. There's always a tiny chance a particle could appear on the other side of a barrier, even if it doesn't have enough energy to go over it. Scientists have observed this in experiments like the double-slit experiment, where particles behave as if they're in multiple places at once, hinting at the existence of parallel realities. If particles can tunnel through barriers, could entire universes do the same? Some theorists suggest that quantum tunneling might not just apply to tiny particles, but could extend to entire universes, creating pathways to parallel realities. While this idea is still in the realm of speculation, it challenges our understanding of what's possible and opens up thrilling new possibilities for the nature of existence. This theory reminds us that the universe is far stranger and more mysterious than we can imagine. Shifting our focus, let's explore the second theory, the many worlds interpretation. This idea suggests that every time a quantum decision is made, the universe splits into multiple realities. Imagine flipping a coin. In one universe, it lands on heads, but in another, it lands on tails. According to this theory, both outcomes are real, each unfolding in its own separate universe. This branching happens at every moment with every quantum event, leading to an infinite number of parallel universes. The concept was first proposed by physicist Hugh Everett in the 1950s as a way to explain the strange behavior of particles at the quantum level. Instead of a single outcome, Everett argued that all possible outcomes actually occur, each in its own distinct universe. While this idea might sound like science fiction, it's grounded in the mathematics of quantum mechanics. Some scientists believe the many worlds interpretation could resolve certain paradoxes in physics, like Schrödinger's famous cat experiment, where a cat can be both alive and dead until observed. In this framework, there's no paradox because both possibilities exist in different realities. This theory opens up a mind-bending view of the cosmos, where every choice, every chance event spawns a new universe. The many worlds interpretation challenges us to rethink not just the nature of reality, but also the role of our decisions in shaping it. Could there be versions of us living out alternate lives in these parallel worlds? The possibilities are as endless as the universes themselves. Now, let's take a dive into the Multiverse Membrane Theory, a concept that stretches our understanding of reality beyond 3 dimensions. This theory comes from string theory, which suggests that the fundamental building blocks of the universe are not particles but tiny, vibrating strings. These strings exist in higher dimensional spaces called branes, short for membranes. Picture our universe as a sheet of paper floating in a higher dimensional space. Other universes could be like additional sheets, each existing in the same space but separate from one another. According to this idea, collisions between these branes could create new universes. It's like two sheets of paper smashing into each other, producing a burst of energy that gives birth to a whole new reality. This concept ties into the cyclic model of the universe, which proposes that the Big Bang wasn't a one-time event but rather the result of a brane collision. In this model, the universe goes through endless cycles of expansion and contraction, with each new cycle triggered by these collisions. What's fascinating is that this theory suggests parallel universe travel could be possible if we could somehow navigate these higher dimensional spaces and move between branes. While this remains speculative, it opens up a thrilling possibility that our universe might just be one of many, all coexisting in a vast cosmic landscape. The multiverse membrane theory challenges us to think in dimensions beyond our everyday experience, offering a glimpse into a reality where universes are born from the echoes of collisions in higher dimensional space. Could we one day find a way to traverse these membranes and explore other realities? The idea is as mind-expanding as it is awe-inspiring. Now, let's venture into another mind-bending concept, the holographic principle. This theory suggests that our universe might not be what it seems. Imagine if everything we experience, every star, every planet, every person is actually a projection from a higher dimensional reality. It's as if our three-dimensional world is a hologram, a kind of cosmic illusion. This idea was first proposed by physicist Leonard Susskind and later developed further by other scientists. They argue that all the information needed to describe our universe could be encoded on a two-dimensional surface, much like how a hologram stores a 3D image on a flat piece of film. But here's where it gets even more fascinating. This principle has deep ties to black holes. When matter falls into a black hole, it's not destroyed instead. Its information is thought to be stored on the black hole's event horizon, the boundary beyond which nothing can escape. This has led some to speculate that black holes could act as gateways to other dimensions or parallel universes. If the holographic principle is correct, it means that our universe is just one layer of a much larger, higher dimensional reality. Accessing these dimensions could, in theory, allow us to travel to parallel universes. While this remains speculative, it opens up a universe of possibilities. Could we one day decode the hologram and step into another reality? The holographic principle doesn't just challenge our understanding of space and time, it redefines the very fabric of existence. It's a theory that invites us to question what's real and what's possible in the grand scheme of the cosmos. Moving on to another intriguing concept, let's explore the idea of wormholes as potential gateways to parallel universes. Often depicted in science fiction, wormholes are theoretical passages through space-time that could create shortcuts between distant points or even different realities. These tunnels, also known as Einstein-Rosen bridges, were first proposed as solutions to the equations of general relativity by Albert Einstein and his colleague Nathan Rosen. At their core, wormholes suggest that space and time can be bent and folded in such a way that two distant locations can be connected by a tunnel, effectively bypassing the vast distances of the universe. But here's the catch. While wormholes are mathematically possible, they come with significant challenges. For one, they are incredibly unstable. Theoretical models predict that a wormhole would require an enormous amount of exotic matter with negative energy to keep it open and stable long enough for anything to pass through. Without this, the wormhole would collapse almost instantaneously. Additionally, even if we could stabilize a wormhole, the journey through it might be far from safe. The intense gravitational forces inside could tear apart anything attempting to traverse it. Despite these hurdles, the idea of using wormholes as gateways to parallel universes remains a tantalizing possibility. If we could somehow overcome these challenges, wormholes might not only allow us to travel across vast cosmic distances, but also enable us to access entirely different realities. While this remains firmly in the realm of theory for now, the concept of wormholes continues to inspire scientists and dreamers alike, pushing the boundaries of what we believe is possible in the cosmos. Now, let's shift our focus to a theory that challenges the very nature of reality itself, the simulation argument. This idea suggests that our universe might not be what it seems. It could be an incredibly advanced computer simulation, much like a video game created by a higher intelligence. If this is true, then parallel universes could simply be other simulations running on the same server, each with its own set of rules and parameters. This theory, often attributed to philosopher Nick Bostrom, proposes that one of three possibilities is likely. Either civilizations go extinct before developing the capability to create such simulations, they choose not to create them, or we are almost certainly living in one. The implications of this idea are profound. If our reality is a simulation, it would mean that everything we perceive, our thoughts, emotions, and the physical world could be nothing more than lines of code. This raises fascinating philosophical questions about free will, consciousness, and the nature of existence. From a scientific perspective, some researchers have even proposed ways to test this theory. For example, if the universe is a simulation, there might be tiny glitches or patterns in the fabric of reality that could reveal its digital nature. While this remains a highly speculative idea, it forces us to reconsider what we believe to be true about the cosmos. If the simulation argument is correct, then accessing parallel universes might be as simple as loading another simulation. This theory, though mind-bending, continues to spark debate and curiosity, inviting us to question the very foundation of what we consider real. Now, let's explore a theory that flips the concept of reality on its head literally. The mirror universe theory proposes the existence of a parallel universe made entirely of antimatter, a perfect mirror image of our own. In this mirrored reality, everything we know is reversed. Particles that make up matter in our universe are replaced by their antimatter counterparts. This idea stems from the symmetry between matter and antimatter, a fundamental principle in physics. When matter and antimatter meet, they annihilate each other, releasing immense energy. But what if, instead of annihilation, there's a delicate balance that allows these parallel realities to coexist? Scientists have long observed that the universe seems to favor matter over antimatter, a puzzle known as the matter-antimatter asymmetry. However, if antimatter universes exist, they could provide the missing piece to this cosmic riddle, suggesting that the universe is far more complex than we've imagined. Imagine a world where the laws of physics are identical but inverted, where left becomes right and time could even flow backward. While this theory remains speculative, it opens up thrilling possibilities for understanding the nature of existence and the potential for multiple realities. If the mirror universe theory holds true, it could mean that somewhere out there, an exact opposite version of our universe thrives, unseen but intertwined with our own. A fascinating thought, isn't it? Shifting our gaze to a broader cosmic canvas, let's delve into the infinite bubble universe theory. Picture our universe not as a solitary entity, but as one bubble floating in an endless sea of cosmic foam. Each bubble represents a distinct universe, complete with its own set of physical laws and dimensions. This idea is rooted in the concept of cosmic inflation, a theory suggesting that just after the Big Bang, space expanded exponentially, creating pockets of energy that evolved into separate bubble universes. These bubbles aren't static, they're constantly expanding, occasionally colliding or brushing against one another. Such collisions could leave behind observable traces, like ripples in space-time or anomalies in the cosmic microwave background. Imagine the possibilities. What if these interactions created new universes or even altered the fabric of existing ones? The infinite bubble universe theory challenges us to rethink the scale of existence, suggesting that our universe is just one thread in an infinite cosmic tapestry. While this theory remains speculative, it invites us to consider the vastness of reality and the potential for countless unseen worlds just beyond our reach. Could these bubble universes hold the key to understanding the mysteries of existence? The thought is as humbling as it is exhilarating. Now, let's explore the captivating idea of the time loop paradox, where time itself becomes a gateway to parallel realities. Imagine a scenario where you're stuck in a time loop, reliving the same day over and over, but with each repetition, subtle changes occur. This concept isn't just a plot device in movies like Groundhog Day. It's a fascinating theory about how time loops could spawn alternate realities. Each loop represents a slightly different version of events, creating a branching series of parallel universes. Think of it like this: every decision you make, no matter how small, could lead to a new timeline. Even if the loop resets, the changes accumulate, resulting in a universe that's subtly different from the previous one. This idea challenges our understanding of time as a linear progression, suggesting instead that it's a dynamic, malleable force capable of creating infinite variations of reality. In essence, each loop is a snapshot of a new universe where the smallest tweak in actions or choices can lead to vastly different outcomes. What if these loops aren't just isolated incidents but part of a larger cosmic mechanism generating parallel realities? The time loop paradox invites us to ponder the nature of time, choice, and the endless possibilities that lie within each moment. Could these loops be pathways to unseen worlds, or are they simply glimpses into the infinite complexity of existence? The answer remains as elusive as time itself. Now, moving into the realm of quantum physics, we encounter the intriguing concept of the quantum entanglement bridge. Imagine two particles so deeply connected that no matter the distance between them, a change in one instantly affects the other. This phenomenon, known as quantum entanglement, has long puzzled scientists with its implications for communication and the nature of reality. But what if this strange connection could go beyond our universe? Some theories suggest that entangled particles might not just bridge vast distances in our own universe, but could also act as gateways to parallel realities. Think of it like a cosmic telephone line where particles on either end are tuned to the same frequency, allowing instantaneous communication across dimensions. The idea hinges on the possibility that entanglement isn't just a phenomenon confined to our universe but could extend into others, creating a bridge between realities. This raises profound questions. Could we use entangled particles to send messages to parallel universes? And if so, what might we discover on the other side? While the technology to test this idea is still beyond our reach, the quantum entanglement bridge opens up a fascinating avenue for exploring the multiverse. It challenges our understanding of space, time, and the very fabric of reality, suggesting that the boundaries between universes might be far more porous than we ever imagined. Now, shifting our focus to the fabric of the cosmos, let's explore the cosmic string hypothesis. Cosmic strings are thought to be incredibly thin, yet immensely dense defects in space-time, remnants from the earliest moments of the universe. Formed during the intense energy fluctuations of the Big Bang, these structures are like cracks in the foundation of reality itself. Picture them as cosmic scars stretching across vast distances and potentially connecting different regions of space or even different universes. Some theorists propose that these strings could act as stable pathways between parallel realities, offering a natural bridge for travel or communication. The idea is that these strings, due to their immense gravitational pull and unique properties, might create distortions in space-time that link to other universes. Imagine them as cosmic highways threading through the multiverse, connecting worlds that would otherwise remain forever isolated. While cosmic strings are still theoretical, their existence could explain some of the universe's most puzzling phenomena, such as anomalies in the cosmic microwave background. If we could detect and study these strings, they might not only shed light on the early universe, but also provide a roadmap to parallel realities. The cosmic string hypothesis invites us to consider that the universe might be filled with invisible threads, weaving together the tapestry of the multiverse in ways we're only beginning to understand. Turning now to the intriguing intersection of consciousness and quantum mechanics, let's delve into the consciousness collapse theory. This idea suggests that our very awareness plays a pivotal role in shaping reality. At the heart of quantum mechanics lies the concept of wave functions, which describe the probabilities of where particles might be or how they might behave. But here's the twist: these wave functions only collapse into definite states when observed or measured. This is where consciousness comes in. Some physicists, like Eugene Wigner, have proposed that it's not just any observation that causes this collapse, it's the act of conscious observation itself. In other words, the universe remains in a fuzzy, undefined state until a conscious mind interacts with it. Now, imagine the implications of this idea. If different conscious states can influence how wave functions collapse, could they also give rise to different parallel universes? Picture this: every decision, every thought, every moment of awareness might branch off a new reality, creating an infinite web of universes shaped by consciousness. While this theory remains highly speculative, it raises profound questions about the nature of reality and our role in it. Could our minds be the architects of the multiverse, weaving together alternate realities with every thought? The consciousness collapse theory challenges us to consider that the boundaries of the universe might not lie in space or time, but in the very fabric of our awareness. Shifting our gaze to one of the universe's most enigmatic mysteries, let's explore the dark matter parallel universe theory. Dark matter, which makes up about 85% of the universe's mass, has long puzzled scientists. Unlike ordinary matter, it doesn't emit, absorb, or reflect light, making it invisible to our current detection methods. Yet, its gravitational effects are undeniable, influencing the rotation of galaxies and the bending of light. But what if dark matter isn't just an unseen component of our universe? What if it's an entire parallel universe, overlapping with ours in ways we're only beginning to imagine? This theory suggests that dark matter could be the fabric of a hidden reality, one that exists alongside our own but remains just out of reach. The interactions between these universes might be subtle, manifesting only through gravitational forces or other faint signals. Think of it like two sheets of paper lying on top of each other, close yet distinct. Could this explain why dark matter is so hard to detect directly? If dark matter is indeed a parallel universe, it opens up a host of fascinating questions. How do these realities influence each other? Could there be dark matter stars, galaxies, or even life forms completely unknown to us? While this idea is still speculative, it challenges us to rethink the boundaries of our own reality. The dark matter parallel universe theory invites us to consider that the universe might be far more layered and interconnected than we ever imagined. As we continue to probe the mysteries of dark matter, we might just find ourselves peering into a hidden cosmos, one that exists in the shadows of our own. Turning now to another captivating idea, let's delve into the black hole portal theory. Black holes, those enigmatic regions of space-time where gravity is so intense that nothing can escape, have long fascinated scientists and science fiction enthusiasts alike. But what if these cosmic phenomena are more than just destructive forces? What if they serve as gateways to parallel universes? At the heart of a black hole lies its singularity, a point where the laws of physics as we know them break down. Some theories suggest that this singularity could act as a bridge, a wormhole connecting our universe to another. Imagine it as a cosmic tunnel linking one reality to the next. However, the journey through a black hole would be far from simple. The intense gravitational forces would stretch and compress anything entering it, a process known as spaghettification. Surviving such an ordeal seems impossible with our current understanding of physics, but if advanced civilizations or future technologies could find a way to stabilize or navigate these pathways, the possibilities would be staggering. Could black holes be the ultimate portals to parallel universes, offering access to realities beyond our own? The idea raises profound questions about the nature of space-time and the boundaries of existence. While the black hole portal theory remains speculative, it challenges us to think beyond the limits of our current knowledge and explore the universe's most extreme environments. As we continue to study these cosmic giants, we might uncover clues that bring us closer to understanding whether they truly are the gateways to other worlds. Now, shifting our focus to a thought-provoking concept, let's explore the anthropic principle and its connection to parallel universes. Have you ever wondered why our universe seems so perfectly fine-tuned for life? From the precise strength of gravity to the exact value of the cosmological constant, even slight changes to these physical constants could render life as we know it impossible. This apparent fine-tuning has led scientists to propose the anthropic principle, which suggests that our universe's conditions are the way they are because they allow for observers like us to exist. But what if this fine-tuning isn't a fluke? Enter the idea of parallel universes. If there are countless other universes, each with its own set of physical constants, it's statistically inevitable that at least one would have the right conditions for life. In this multiverse scenario, our universe is just one of many, and we happen to inhabit the one where the constants align perfectly for our existence. This theory not only offers an explanation for the fine-tuning mystery, but also raises profound questions about the nature of reality. If other universes exist, what would they be like? Could some harbor life forms adapted to vastly different physical laws? And what does this mean for the uniqueness of our existence? The anthropic principle, combined with the multiverse idea, challenges us to reconsider our place in the cosmos and the very fabric of reality. While the existence of parallel universes remains unproven, the theory provides a compelling framework for understanding the delicate balance that makes life possible in our universe. As we continue to explore the mysteries of the cosmos, the anthropic principle invites us to ponder not just how we came to be, but whether we are truly alone in the vast tapestry of existence. Now, moving into a realm that stretches our imagination, let's delve into the extra dimensions theory. What if the universe we see, length, width, height, and time, is just the tip of the iceberg? String theory, one of the most ambitious frameworks in physics, proposes that our universe might have not just 3 dimensions of space, but up to 10 or even 11 dimensions. These extra dimensions, hidden from our everyday perception, could be curled up or compacted in ways that make them invisible to us. But here's where it gets fascinating. These hidden dimensions might serve as gateways to parallel universes. Imagine these extra dimensions as tiny, folded spaces existing all around us, potentially housing entire universes just beyond our reach. If we could somehow access or unfold these dimensions, it might be possible to travel to these parallel realities. The challenge, of course, lies in understanding how to interact with these dimensions. While string theory provides the mathematical foundation for their existence, experimental evidence remains elusive. Yet, the idea of extra dimensions opens up thrilling possibilities. Could advanced civilizations in other universes have figured out how to traverse these dimensions? And if so, could we one day unlock the secrets to doing the same? The extra dimensions theory not only expands our understanding of the cosmos, but also invites us to question the very nature of reality itself. As we peel back the layers of the universe, who knows what extraordinary discoveries await us in the hidden folds of space and time. Now, let's expand our view even further with the cosmic inflation multiverse theory. In the moments after the Big Bang, the universe is thought to have undergone an explosive period of rapid expansion known as cosmic inflation. This process stretched the fabric of space-time at an unimaginable rate, creating regions that evolved into separate universes, each with their own unique physical properties. These so-called pocket universes could exist alongside our own, forming a vast multiverse. But how do we know this inflation even happened? The evidence lies in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Tiny fluctuations in this radiation suggest that rapid expansion occurred, smoothing out the universe while also seeding the formation of galaxies and other cosmic structures. The implications of this theory are staggering. If inflation created multiple universes, each could have different laws of physics, constants, and even dimensions. Some might be barren, while others could teem with life. This raises profound questions about our place in the cosmos. Are we just one universe among countless others? And if so, could travel between these universes ever be possible? While the idea remains speculative, the cosmic inflation multiverse theory challenges us to rethink the boundaries of reality and consider the infinite possibilities that might lie just beyond our observable universe. Shifting our focus to a truly mind-bending concept, let's explore the Boltzmann-Brain paradox. Picture this. In a universe that's infinitely old and chaotic, random fluctuations in energy could theoretically give rise to self-aware entities' minds that exist without bodies, without histories, and without any connection to the physical world as we know it. These hypothetical constructs, known as Boltzmann brains, are named after the physicist Ludwig Boltzmann, who first proposed the idea. But how does this tie into parallel universes? Well, if these random fluctuations can create conscious observers, it's possible that entire parallel realities could emerge from such chaotic events. Imagine a universe where consciousness exists not in complex organisms, but as isolated, spontaneously formed entities. The implications are staggering. It challenges our understanding of reality itself. Are we real observers, or could we just be the product of a random quantum fluctuation? This theory raises profound philosophical questions about existence, consciousness, and the very nature of the universe. While it's a bizarre and speculative idea, the Boltzmann brain paradox forces us to reconsider what it means to be real and whether the universe might be far stranger than we've ever imagined. Now, let's turn to a theory that blurs the line between life, death, and the infinite possibilities of the multiverse, the quantum suicide and immortality theory. At its core, this idea builds on the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of a quantum event spawns a new parallel universe. But here's the twist. If this is true, could it mean that consciousness is, in a sense, immortal? Imagine a scenario where someone repeatedly faces a life or death situation, like pulling the trigger of a quantum-loaded gun. In some universes, the gun fires and the person dies, but in others, the gun misfires and they survive. According to this theory, the observer's consciousness would only continue in the universes where they live, effectively making it impossible for them to experience their own death. From their perspective, they would always survive, no matter how unlikely the odds. This raises profound ethical and philosophical questions. If consciousness is tied to survival across infinite universes, does that make us immortal in some sense? And what does this mean for our understanding of life, death, and free will? While this theory is deeply speculative, it challenges us to rethink the nature of existence and the boundaries of what it means to be alive. It's a thought experiment that pushes the limits of both science and philosophy, inviting us to consider just how far the rabbit hole of parallel universes might go. Now, let's explore a theory that takes us into the fascinating world of what if. The parallel universe evolution theory suggests that parallel universes could have evolved in entirely different ways based on their initial conditions or even random events. Picture this: in one universe, a key moment in history, like the outcome of a battle or the discovery of a scientific principle, took a different turn. This single change could ripple through time, shaping a reality that looks nothing like our own. For example, imagine a universe where dinosaurs never went extinct. In that world, mammals might never have risen to dominance, and humans could be a species that never existed. On the other hand, consider a universe where a different political leader rose to power, altering the course of global events and creating a timeline where technology, culture, or even geography evolved in unexpected ways. The beauty of this theory lies in its emphasis on how small changes can lead to vastly different outcomes. It's like the butterfly effect on a cosmic scale, where one tiny difference at the start can create an entirely new reality. This idea also ties into the concept of alternate evolutionary paths, where life itself could have taken a completely different form. Perhaps in another universe, intelligent life evolved from insects or aquatic creatures, leading to societies and technologies that are beyond our imagination. The parallel universe evolution theory not only ignites our curiosity about the infinite possibilities of existence, but also invites us to reflect on the delicate balance of events that shaped our own universe. It's a reminder that the story of reality is far from predetermined, and every moment holds the potential for a new chapter. Building on the idea of alternate realities, let's shift our attention to the cosmic microwave background radiation, often referred to as the universe's afterglow. This faint radiation, left over from the Big Bang, serves as a snapshot of the early universe, and intriguingly, it might hold clues about interactions with parallel universes. Scientists have discovered anomalies in this radiation, regions where the temperature fluctuations don't align with our current understanding of cosmology. These irregularities could be evidence of collisions between our universe and other bubble universes in the vast multiverse. Imagine our universe as one bubble in a cosmic foam, where neighboring bubbles occasionally brush against each other. These collisions could leave imprints in the cosmic microwave background, like fingerprints on a window. For instance, certain cold spots or unusual patterns in the radiation might be signatures of such encounters. While this interpretation is still speculative, it opens up exciting possibilities for understanding the multiverse. These anomalies could be the first tangible evidence that we're not alone in the cosmic expanse, and that our universe is just one of many. By studying these subtle clues, scientists aim to piece together the puzzle of parallel universes and their potential connections to our own. It's a reminder that even the faintest whispers from the early universe can tell us stories about realities beyond our own. Now let's take a step back in time, all the way to the very first moments after the Big Bang. During this incredibly hot and dense phase, the universe wasn't filled with the atoms and particles we know today. Instead, it was a seething, chaotic soup of quarks and gluons, the fundamental building blocks of matter, swirling together in a state known as quark-gluon plasma. This exotic form of matter, which only existed for a fleeting moment, might hold the key to unlocking pathways to parallel universes. Scientists have recreated quark-gluon plasma in particle accelerators like the Large Hadron Collider, where collisions at nearly the speed of light mimic the extreme conditions of the early universe. These experiments have revealed fascinating properties, such as the plasma's near-perfect fluidity and its ability to behave like a single, unified entity rather than individual particles. Some researchers speculate that this unique state of matter could have created transient portals or bridges to other dimensions or universes. If true, it means that the universe's very first moments might have been a time of not just creation, but also connection, linking our reality to others in ways we're only beginning to understand. While the idea of quark-gluon plasma serving as a portal to parallel universes remains theoretical, it offers a compelling glimpse into how the study of particle physics might one day uncover the secrets of the multiverse. By peering into the earliest moments of existence, we could find clues to realities far beyond our own. Now, shifting our focus to the relationship between time travel and parallel universes, let's explore how these two concepts might be deeply intertwined. The idea of time travel often conjures images of moving backward or forward within a single timeline. But what if it's not that simple? According to some theories, traveling through time could inherently mean traveling to a parallel universe. This concept is rooted in the idea of branching timelines, where every decision, every event creates a new reality. For example, if you were to travel back in time and alter an event, the outcome might not play out in your original universe but instead create a new, parallel one. This raises fascinating questions about causality. If every action spawns a new timeline, does that mean our past, present, and future are constantly branching into infinite possibilities? And if so, could time travel ever truly allow us to return to the same universe we left? These questions challenge our understanding of cause and effect, suggesting that the fabric of reality might be far more complex than we imagine. By examining the connection between time travel and parallel universes, we open the door to a universe or multiverse where the rules of time and space might be rewritten entirely. Turning our attention to the role of quantum gravity, we find a theory that could potentially bridge the gap between parallel universes. The idea of a quantum gravity bridge is rooted in the quest for a unified theory that combines the principles of quantum mechanics and general relativity. These two pillars of modern physics describe the universe at vastly different scales: quantum mechanics dealing with the very small and general relativity with the very large. Yet they remain stubbornly incompatible. A unified theory of quantum gravity would not only resolve this incompatibility, but could also provide a framework for understanding how parallel universes might be connected. Picture spacetime as a vast, interconnected web where gravity reimagined through quantum principles could create pathways between universes. This concept suggests that the fabric of reality might be woven together in ways we've yet to fully comprehend. However, the challenges are immense. Reconciling the probabilistic nature of quantum mechanics with the deterministic framework of general relativity is no small feat. It requires rethinking some of the most fundamental aspects of physics, from the nature of spacetime to the behavior of matter and energy. Despite these hurdles, the pursuit of quantum gravity offers tantalizing possibilities, potentially unlocking the secrets of how parallel universes interact or even overlap. As we explore this theory, we're reminded that the journey to understand the cosmos is as much about the questions we ask as the answers we seek. Shifting our gaze beyond the confines of Earth, let's explore a fascinating idea. Could advanced alien civilizations hold the key to parallel universe travel? The alien technology hypothesis suggests that extraterrestrial beings, far more technologically advanced than humans, might have already unlocked the secrets of accessing alternate realities. Imagine a civilization millions of years ahead of us, harnessing energy and understanding physics in ways we can't yet fathom. Such a species could have developed devices or methods to traverse the multiverse, bending the laws of the cosmos to their will. This idea ties intriguingly into the Fermi paradox, which famously asks, where is everybody? If the universe is teeming with life, why haven't we encountered evidence of it? One possible answer lies in the realm of parallel universes. Advanced alien civilizations might not be missing. They could simply exist in realities beyond our reach, using their superior technology to explore or even colonize other dimensions. This hypothesis raises profound questions about the nature of intelligence and our place in the multiverse. While we're still grappling with the basics of space exploration, it's humbling to consider that somewhere, or perhaps someone, other beings might already be navigating the vast tapestry of parallel worlds. As we ponder this possibility, the mysteries of the cosmos grow even deeper, inviting us to expand our understanding of what might truly be out there. Now, let's take a closer look at the intriguing potential of zero-point energy and its connection to parallel universes. According to Theory 26, the quantum vacuum, which is the lowest possible energy state in the universe, holds an infinite amount of energy. This energy, known as zero-point energy, exists even in seemingly empty space and could, in theory, be harnessed to create pathways to alternate realities. Imagine tapping into this limitless source to power a portal that bridges our universe with others. The concept suggests that by manipulating the quantum vacuum, we could access the multiverse, opening up possibilities for travel and exploration that are currently beyond our imagination. However, the challenges of harnessing zero-point energy are immense. The energy is fleeting and difficult to extract, requiring technology far beyond our current capabilities. Additionally, the precise mechanisms for creating a stable portal remain purely speculative, as our understanding of quantum mechanics and the nature of space-time is still incomplete. Despite these obstacles, the idea of a zero-point energy portal offers a tantalizing glimpse into the future of interdimensional travel. It pushes the boundaries of what we believe is possible, encouraging us to rethink the very fabric of reality. As we continue to explore the mysteries of the quantum world, the dream of unlocking parallel universes through zero-point energy remains one of the most fascinating frontiers in science. Now, shifting our perspective, let's delve into the fascinating concept of the fractal universe. This theory suggests that the structure of our universe is not random but follows a pattern of self-similarity, much like the branching of a tree or the intricate design of a snowflake. In a fractal universe, smaller universes exist within larger ones, creating a nested, interconnected web of realities. Imagine zooming into a seemingly ordinary space only to discover an entire cosmos hidden within, complete with its own galaxies, stars, and perhaps even life. The fractal nature of the universe could mean that parallel realities are not distant or separate but intricately woven into the fabric of our own. If this theory holds true, accessing parallel universes might not require crossing vast distances but rather navigating the layers and scales of reality itself. This idea challenges our traditional understanding of space and time, suggesting that the key to interdimensional travel could lie in mastering the fractal geometry of the cosmos. While still speculative, the fractal universe theory opens up a new way of thinking about the multiverse, one that blends mathematics, physics, and imagination into a unified vision of existence. As we continue to explore this concept, we may find that the boundaries between realities are far more fluid than we ever imagined. Moving forward, let's explore a theory that challenges the way we think about the cosmos, the plasma universe hypothesis. Unlike the standard cosmological model, which focuses on dark matter and gravity as the dominant forces shaping the universe, this theory suggests that plasma, the fourth state of matter, plays a central role in the structure and behavior of the cosmos. Plasma, which consists of charged particles, makes up more than 99% of the visible universe and is responsible for phenomena like solar winds, auroras, and lightning. In this model, vast networks of plasma filaments weave through space, forming intricate structures that could act as cosmic highways. These filaments might not only shape galaxies and star systems, but could also serve as bridges to parallel universes. Imagine these plasma pathways as threads connecting different realities, allowing for the possibility of travel between them. The plasma universe hypothesis contrasts sharply with traditional models, emphasizing electromagnetic forces over gravity and proposing a more dynamic, interconnected cosmos. While still a subject of debate, this theory offers a fresh perspective on the universe's architecture and its potential links to other dimensions. By viewing the cosmos through the lens of plasma physics, we might uncover new pathways to understanding and perhaps even accessing parallel realities. Now, let's shift our focus to a theory that ties the fabric of reality to the act of observation itself, the observer effect and parallel realities. In the strange world of quantum mechanics, the observer effect suggests that simply measuring or observing a system can alter its state. This means that reality, at its most fundamental level, isn't fixed until it's observed. A classic example of this is the famous thought experiment involving Schrödinger's cat. In this scenario, a cat inside a sealed box is both alive and dead until someone opens the box to check. The act of observation collapses the cat's state into one reality, either alive or dead. Extending this idea, some theorists propose that every possible outcome of a quantum event could exist simultaneously, each in its own parallel reality. In other words, the universe might branch into multiple realities every time an observation is made. For instance, if you choose to turn left instead of right at a crossroads, one universe might see you taking the left path while another sees you going right. These realities would coexist, diverging based on the choices and observations made. This interpretation blurs the line between the observer and the observed, suggesting that our very awareness could shape the universe around us. While this idea remains speculative, it challenges our understanding of reality and opens up fascinating possibilities about the nature of existence. Could every decision we make send us down a different path in the multiverse? The observer effect invites us to consider how deeply intertwined our consciousness might be with the fabric of the cosmos. Now, let's journey into the final frontier of our exploration, the concept of the eternal inflation multiverse. Imagine a universe that never stops expanding, not just our own, but countless others, endlessly bubbling into existence. This is the essence of eternal inflation, a theory that suggests our cosmos is just one of an infinite number of universes constantly being born. Here's how it works. In the early moments after the Big Bang, the universe underwent a period of rapid expansion known as cosmic inflation. But what if this inflation never truly stopped? Instead of slowing down, certain regions of space could continue to inflate, giving rise to new universes with their own unique physical laws and properties. These universes would exist in a vast cosmic landscape, disconnected from one another yet all emerging from the same initial burst of expansion. The implications of this theory are mind-bending. If eternal inflation is true, it means reality is not just vast but infinite, with every possible variation of existence playing out somewhere in the multiverse. Some universes might be nearly identical to ours, while others could be wildly different, governed by entirely different rules of physics. This idea challenges our understanding of existence itself, suggesting that our universe is just a tiny bubble in an endless sea of possibilities. While the concept remains speculative, it pushes the boundaries of science and philosophy, inviting us to wonder just how big reality truly is. Could there be other versions of you living different lives in parallel universes? The eternal inflation multiverse leaves us with more questions than answers, but it's a fascinating glimpse into the infinite nature of existence. Wrapping up our journey, we've explored 30 mind-expanding theories about the first parallel universe travel, each offering a unique glimpse into the mysteries of existence. From the quantum tunneling hypothesis to the eternal inflation multiverse, these ideas span the realms of physics, philosophy, and imagination, revealing just how vast and complex our reality might be. Whether it's the idea of wormholes as gateways to other dimensions or the possibility that dark matter hides a parallel universe, the diversity of these theories reminds us that the universe is full of wonders waiting to be uncovered. While some ideas challenge our understanding of science, others push the boundaries of what we thought was possible, inviting us to dream bigger and question deeper. What's your favorite theory? Drop a comment below and let us know which one sparked your curiosity the most. Don't forget to subscribe and hit the notification bell so you never miss a deep dive into the mysteries of the cosmos. Thanks for joining us on this incredible journey through the multiverse. Until next time, keep exploring.